All right, hello. Welcome back again to another edition of Algebra 2. I'm Mr. Anderson. We're in section 8.6 today. So we're talking about solving rational equations and inequalities. Remember, when we talk about rational expressions, basically it's a fraction with some polynomials in it. Okay, so that's where we're going to deal with some solving equations today. Our objectives: solve rational equations and solve rational inequalities. All right. So first of all, remember, rational equations, like I said, they contain one or more rational expressions, which means a rational expression, remember, has got basically it's a fraction in there. It's got a fraction with a polynomial of some sort. So they're often easier to solve once the fractions are eliminated. So that's what we're going to try to do today, is get rid of the fraction, and then we'll just solve what's left. And I guess I need to move my calculator here. Then eliminate the fractions. Here's how we're going to do it. We're going to get rid of the fractions by multiplying each side, everything on both sides of the equation, by the lowest common denominator. Remember, we were talking about that in the last section as the least common multiple. And so if we multiply everything on both sides by the common denominator, basically what's going to happen is it'll cross out every fraction, and what's left will not be a fraction. Okay, so let's see how that's going to work. So let's see how that's going to work. I'm going to move this back up here. All right, so here's an equation. You notice we've got all these fractions in here. So first thing that we have to do is we need to find out what's the common denominator here that we can multiply everything by. Okay, so first of all, remember when we were talking about least common multiple, we're taking each factor and choosing the one that had the most in each part, I guess you could say, the one that had the most factors. So for example, 24 breaks down to what? 6 and 4. 6 would go down to 2 and 3. 4 would be 2 and 2. So in other words, for 24, we've got what? 2 to the third power and 3. Okay, so you got 2 to the third power and 3. And with 4, we've got 2 times 2, which is just 2 squared. And then, of course, for the 3 minus x, that's the only factor we've got. We think of that as being in parentheses. So what you want to do then is you want to go, okay, well, what's the least common denominator or least common multiple of those? You take the biggest time that each factor came up. So for example, the factor of 2 came up 3 times here and 2 times here. We're going to choose the 3 times. So in other words, that's 2 to the third power. Factor of 3 came up here. It didn't come up anywhere else. Remember, this is not a 3, this is a 3 minus x. So we're going to use all of these, the 2 and the 3 from there. This is the only time the 3 minus x factor comes up, so we're going to use that. And 2 squared, we didn't use that because we used the 2 to the third. So basically what we're using here is all of this, which is 24, and the parentheses. So our least common denominator here is 24 and 3 minus x. Now here's what's going to happen. Okay, so what I'm going to do is I'm going to multiply each one of these fractions by this, which was the least common denominator. So I'm going to take 24 and 3 minus x times 5 over 24. So it's times this first one here. Then we have plus, and then I'm going to take the 24 and the 3 minus x times this fraction here. So 2 over 3 minus x, think of that as being in parentheses, equals, and then we got the 1/4, and times 24, 3 minus x. So here's what happens now. I took each part. See, here's the 5/24 from here. The 2 over 3 minus x is right here, and the 1/4 is right here. So I took each one and multiplied by this common denominator. And what's going to happen is it's going to cross out each one of these fractions. So this 24 will cross out that 24. What's left? This 5 times 3 minus x. I can distribute that, so that's going to be 15 minus 5x. Okay, what's next? On the next one, this whole 3 minus x will cross out that whole 3 minus x. What do we have left? 2 times 24, which is plus 48. Then over here, we've got, remember this is like over 1, so this 4 will cancel out here and leave me with 6 up here. So what do we have left is basically we just distribute the 6, and that's going to be 18 equals 18 minus 6x. Okay, that's distributing that. So here's the resulting equation now that I have multiplied everything by the common denominator, and that's okay because remember, as long as you multiply everything on one side and everything on the other side by the same thing, it stays balanced. Remember that back from Algebra 1? So now let's just start solving this. I'm going to get the x's together, plus 6x, plus 6x. These cancel. So that leaves me with just an x. Here, I'm going to combine the 15 plus 48. So that's going to be plus 63 equals 18. And then the last thing I have to do here is minus 63. Cancel, cancel. X equals a negative 45. Okay? So, now the one thing you got to keep in mind here is this. Because these are fractions, remember whenever we get a 0 on the bottom of a fraction, that can't happen. That doesn't work. Mathematically, we can't divide by 0. So if you, basically what you're looking for is here, if this would have worked out to be x equals 3, notice here 3 minus, if that was 3, that'd be 0. So that would not work. Okay, so got to watch out for that, but if you want to plug this back in, you should be able to find that this does work once you plug it back in. So you've got your 5/24 plus, and then if you plug negative 45 in here for x, that's really plus, minus a negative, which is plus a positive, so that's 2 48 equals 1/4. We could reduce this fraction here, so 5/24 plus 1/24. Does that equal 1/4? Well, this, when you add it together, is really 6/24. And so that would reduce. Divide by 6 to get 1, divide by 6. And so, yeah, that works. So you can see it worked. But that's the big thing to watch out for, is making sure that this under here cannot equal 0. Okay? All right. That's example number 1. Example number 2. It looks a little harder. But remember, what we want to do is we want to find out what the denominators have that are the same. So what I would suggest here with this trinomial is to factor it down. Remember the type of factoring we did with trinomials? Where we're going to break it down to 2 parentheses here. We said what times what is 15, but adds up to be 8. I'll let you think there for a second. What times what is 15, but adds up to be 8? Did you say plus 3 plus 5? If you did, excellent. So we factored this down. So now when we look at the denominators here, we say, well, what could be the denominator that they all have? Well, basically, again, each factor, you know, here this has an x plus 3, this has an x plus 3. This has an x plus 5, this has an x plus 5. So our least common denominator, the thing that we could get them all to be, would be x plus 3, x plus 5. Okay? So that would be our common denominator. One factor of x plus 3 and one factor of x plus 5. So let's multiply that times each, if I can fit it all in here, 2x over x plus 5. Multiply it by that one. Then multiply the x plus 3, x plus 5 times the, I hope I don't run out of room here, x squared minus x minus 10 And I'm going to, instead of writing it as this trinomial, I'm just going to write it as the factored down version there. And then that equals 3 over x plus 3 times x plus 3x. Darn it. Wonder if I can... plus 5. Okay, you get the idea. I don't know if you can quite see it on the edge over there, but that's an x plus 3 times x plus 5. So let's cross out whatever we can. This x plus 5 down here we'll cross out with that x plus 5. What do we have left here? Distribute this 2x. Okay, so that's going to be 2x squared plus 6x. Here, x plus 3 can cancel the x plus 3, x plus 5 can cancel the x plus 5. Notice we still have got this negative right here, so we have to distribute that negative through this trinomial here. So that's going to be minus x squared minus a negative is plus x, and then minus a negative is plus 10 equals, and then this x plus 3 cancels that x plus 3, and then we just distribute the x, or the 3 to the x plus 5, so that's going to be 3x plus 15, I think. Okay, so that's our new equation there, no more fractions. Let's, now you notice here, we've got some x squareds and some x's, so unlike before, we're not going to just be able to get x by itself. X equals a number. So what happens when we've got like an x squared in there? We get it all together on one side equal to 0, and we'll try to factor it. Okay, and that should work in this case. So I'm going to go here. I've got 2x squared and minus x squared, so that's going to give me 1x squared. I've got 6x plus 1x is 7x. And then I've got the plus 10. So I got all the stuff on the same side together. Let's move this x over, minus 3x. And move this 15 over, minus 5. Oh, minus 15, sorry. Wow. I think I was thinking ahead on that one. So now what we've got is x squared plus 4x minus 5 equals 0. Right? Let's factor it. What did we do before? What times what is negative 5 but adds up to be 4? So what times what is negative 5 but adds up to be 4? That's going to be 5 and negative 1. So this would factor down to x plus 5, x minus 1. And remember what we did here before? When we solved these, made each one equal to 0. So in this case, we say, well, x could equal a negative 5. And here, x could equal a positive 1. Now, notice one thing. Remember what I talked about getting a 0 on the bottom of a fraction? If you look closely here, look at the two possibilities. You know, the x plus 5 and we had an x plus 3. That means we cannot have a negative 5 or a negative 3 as an answer. Otherwise, it makes a 0 on the bottom, and that's no good. And if you notice, look at one of our solutions here was x equals a negative 5. So guess what? If I plug this back in here, I will get 0 on the bottom of this fraction, and that's no good. So I have to cancel out that answer. I'm not going to take the time to go into it, but if you take 1 and you plug 1 in here, that should work. So in this case, 1 is our only answer. Okay, so there's another one solving a rational equation. All right, next, rational inequalities. Okay, it's going to be very similar, but what we're going to do here is the first step is we're going to state the excluded values. Remember, the excluded value was what I was just talking about. That's the negative 5 that we just had, the value that makes 0 on the bottom of the fraction. So that is something that we cannot have, so that's a key point. And so we're going to make note of that. Then we're going to solve what our inequality is, just as if it was an equation, just like we just did. And then we'll see what numbers we get from that, and then we'll look at a on a number line where those key points are, and just try some sample points and see which one or ones work. Okay. All right. So here's example 3. We're going to solve a rational inequality. All right. So remember what I just said there was we need to figure out what makes 0 on the bottom of each of these fractions. Either this one or this one. It's actually the same thing. X cannot equal 0. 0. If x was 0, this would be 0. If x was 0, 0 times 5, you'd still get 0 on the bottom of that one. So that's a key point, is 0. Now we'll solve what's left here like we've just done in the previous 2 examples and find out what other point or points are key points, and then we'll finish solving it from there. So again, remember to find a common denominator. If you look here, they all, we've got a factor of x and we've got a factor of 5. So the GCF here is 5x. So we're going to go 5x times 1 over x plus 5x times 3 over 5x, and then 2 over 5 times 5x. So in this case, the x's cancel. What do I have left? 5 times 1 is 5. Here, the 5 and the x both cancel. So we have plus 3. And then over here, the 5's cancel, and what's left is 2 times x, or 2x. So we've got 8 equals 2x, divide by 2. X equals 4. So here are our 2 key spots. I'm going to draw a number line here. 0 is a key spot because that's what causes this to be 0 on the bottom. And when we solved this, 4 was another key spot. So what we want to do now is just try a point to the left of 0, in between, and greater than, and see what makes this inequality work. Okay, so first of all, let's try, I don't know, maybe -1. Okay, this will be to the left of 0 here. So if we plug -1 in here, we've got, oh, let me draw a squiggly line there. So you've got 1 over a -1 plus 3 over, that's going to be -1 times 5, so -5 less than 2/5. So, so this would be -1 plus a -3/5. So that's going to be a bigger negative number there. But let's see, just to get the exact number, -5/5 plus -3/5. So it looks like that's going to be a -8/5. Is that less than 2/5? Remember, 2/5 is positive. -8/5 is negative. So yeah, that looks like that's going to be true. Again, maybe it'll help to draw like a dotted line here so we can see what we're looking at. So this is true out here. All right, let's pick something in between. How about 2, maybe? Or actually, let's try 1. Let's do a positive 1. So this time we've got 1 over 1 plus 3 over 5 times 1, or 3/5, less than 2/5. So this is going to be 5/5 plus 3/5, which is 8/5. Is that less than 2/5? No, that's bigger. That's actually bigger than 1. So that would be false in here. And then lastly, let's pick something out here. I don't know, we'll just try 5 maybe. See what happens there with 5. And so you've got 1 over 5 plus 3 over 25, less than 2/5. And remember, this would be 5 25ths plus 3 25ths. So 5 25ths, which is the same thing as what? Divide by 5, divide by 5. That'd be 1/5. So is 1/5 less than 2/5? Yes, that is. So it looks like, so it looks like here that it's true to the left of 0 and to the right of 4, and so our answer here would be that x has to be less than 0 or x has to be greater than 4. Okay? Kind of a lot of finagling around there, but basically you've got to find out what are the key points and then just test some points. And again, now I kind of did all this, you know, by hand here with the fractions, but there is a calculator that we can use, and you could go ahead and when you're checking your work here, I guess you could plug it in your calculator. That might help you a little bit as well. So you do have that always. All right, last one. Last one. Hopefully last one. There we go. So again, the first thing is we're going to see what makes 0 on the bottom of the fraction. In this case, the only thing that x could be would be 2. So a key point here is that x cannot equal 2. So that's one of our key points. And then we're going to solve this as an equation. The greatest common denominator, or least common denominator here, is 3, one factor of 3, a factor of x minus 2, and then 2 2's, or a 4 here. So the total here would be 12. X minus 2 is the total common denominator there. So we're going to take that times x over 3, and then minus, again, the 12 x minus 2 times 1 over x minus 2, and then equals the x plus 1 over 4 times 12 times x minus 2. And we'll cross out everything we can. So this 3 will cross out, and then cross out the 3 in that and leave me with a 4 there. So actually what we've got here, ooh, this is getting interesting now. You've got, distribute this 4, so that's 4x minus 8, but then you also still have to go times that x there, so I'll distribute that in the next step. This whole thing cancels, so minus 12. Negative 12 times 1. Here, this 4 will cancel with this and leave me with 3. And again, we can distribute that. It's going to have to now be also multiplied by x plus 1. So we've got x plus 1 times 3x minus 6, it looks like there. Okay? It's a little more interesting here, isn't it? All right, distribute the x. So 4x squared minus 8x minus 12. And then here, FOIL. X times 3x is 3x squared minus 6x plus 3x. And then that's this one, and then minus 6. Notice again, we've got some x squareds and x's in here. So that means we can't just get x by itself. We're going to have to get everything together on one side and try to factor. Is what we're going to try to do there. So let's see here. Why don't we go with, yeah, let's go minus 3x squared. I'm going to go with that. So these cancel. That leaves me with an x squared. Let me go ahead and combine these here. Negative 6x and 3x is a negative 3x when we combine those. So to move it over, plus 3x, plus 3x. So these cancel. That's going to give me minus 5x. And then plus 6, minus 6. And so now we factor, just like we have done before. What times what is negative 6 but adds up to be a negative 5? That's going to be a negative 6 and 1. So this ends up being x minus 6 and x plus 1 equals 0. So x would equal 6 and x would equal, whoop, and x would equal -1. So 6 and -1. Okay, so oh yeah, again, these are just kind of our key spots here now. So what we've got is our number line. So we've got a spot here at -1, and then a spot at 2, and a spot at 6. And so we've got to test 1, 2, 3. We've got to test 4 different things here. And just, I'm going to say in the matter of time, since I think we're getting a little bit longer here, if you plug these in, like here, and this is a problem I got from the book. So if I plug in here, the book plugged in a -3, and that worked. Then they plugged in 0, which would be in here, and that did not work, so that's a false. And then between 2 and 6, plugged in a 4, and that worked. That was true. And then out here to the right of 6, they plugged in 8, and that was false. That did not work. So what you would have to say then here, and on your 2 parts, you're going to say that here's our key point here, was -1, 2, and 6. And so since it's true to the left of -1, you'd say x is less than -1. And since it's true in between 2 and 6, then you'd say or x is less than 6, greater than 2. Again, I'm just saving a little bit of time so that we don't have to plug in all this stuff. But that's what's going to happen there, is you find out what's true and what's not true. And again, if you really, really need to, you've got a calculator, you can use that and plug in numbers to help you see what's true and what is not true. So that's it. Solving rational equations, solving inequalities. Basically, the whole goal is you're trying to get rid of the fraction and then solve what's left over is basically it. So thanks for joining me. This is probably it for the year, so I guess I will not see you again next time. But thanks for joining me. Mr. Anderson signing off.